This is a tutorial for the Doppler Effect simulation. So starting up, we'll have this fire truck here emitting sound waves. And those black lines represent the compressions, let's say, of... I guess a siren is not a great example because the siren naturally alternates between two pitches. But you could just say that the fire truck is, blaring its horn at a constant frequency. If you pick 3D mode, it just kind of adds a nice little almost three-dimensional perspective as well as a transverse wave. But for now, we'll just keep it on normal mode. The bottom slider here is the Mach number, so you can give it Mach 0.66, let's say, and you can clearly see the compression of the waves in front with shorter wavelength and higher pitch, and the longer wavelength and lower pitch behind the truck. And you can go up to Mach 1 with the fire truck. So that's the kind of, if you just click back here, it will reset the fire truck. You can click wherever you want. That's the basic mode. The second mode, if you click on jet, the jet mode allows you to go faster than Mach 1. So, you could go to Mach 1.85, and of course it gets even ahead of the sound. And if you click on cone, you can even talk about Mach cones. And, if you watch those videos of jets breaking the sound barrier, the kids can see nice formation of clouds along the Mach cone there. And of course, if you increase the Mach number, you can also show that the Mach cone decreases in angular size. Shuttle reentry, I just added this because I looked up how fast shuttles move on reentry, and apparently they're Mach 25, which is pretty ridiculous. Because the Doppler effect applies to all waves, even though this is a grade 11 topic, I also talk about the Doppler shift of galaxies. So if you click on star mode, I show the spectral emission lines. I don't remember exactly where I got these values from. I think these bands are for hydrogen and helium when I created this simulation. But regardless, you can adjust the relative speed of the star, and if it's moving towards you, if you give it a positive speed, I guess for towards you, you can see that those spectral lines are blue shifted, and if it's moving away from you, you can see that the spectral lines are red shifted. The final thing you can do is click on Hubble, and if we imagine that we are the Milky Way, this is designed to show Hubble's law, that all the galaxies are red shifted and that the farther away you go, the more redshift you get. So I usually say, I'll highlight this galaxy and ask the students, what kind of shift is this? And they'll say it's a red shift. So how is it moving? Oh, it's moving away from us. And then Hubble looked at this galaxy, and that's also red shifted. And then he looked at this one. So you keep going. And as you move farther away, I actually made the redshifts increase in the simulation. So you can have the students, you could ask them these questions on a worksheet, and you could have them come to these conclusions just by looking at the galaxies. And in real life, as far as I understand, every single galaxy you could look at, with the exception of a few local ones, they are all red shifted. And that is what I showed. I did not show any local galaxies being blue shifted in this simulation. So I hope you find this one helpful.